Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very complex infinite equation. We have an infinite fraction, a continued fraction with z plus 1 over z plus 1 over z plus 1. You get the idea? It's a pattern. And the whole thing is equal to I. And we're going to be solving for z values. But guess what? After we find a solution, we're going to plug it in and try to check the validity of the solution, at least by substitution, if it satisfies the original problem. There is also the issue of convergence here. Is this convergent? Like, are we going to be able to find a finite value? Well, it looks like the result is finite. Is I finite? I think so, right? At least we know it's not infinite, right? It's a constant. Even though it's not real, that's fine, right? So is this even possible, right? Something to think about, not to talk about. I mean, you can talk about it in the comment section down below, because I'll be lazy and not talk about those things that much. So let's keep it simple. And when you have an equation like this, what do? I could probably approach it from two different angles. One is going to be, I like to subtract z from both sides. You know why? Just for fun. 1 over z plus 1 over z plus 1 over dot 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 is equal to I minus z. And then are we going to square both sides? No, not really. I just want to look at this equation and I want to realize, okay, the original expression was equal to I, so this should be the same as I, right? So like maybe I can, but I don't want to do that. I want to save it for something else. But before we get into more depths, let's go ahead and take a look at Wolfram Alpha. Do you think Wolfram Alpha can solve this problem in its current form? What do you think? Ideas? Ta-da! Here we go. Wolfram Alpha doesn't understand your query. Too bad, Wolfram Alpha. You should do better. Now, and I know some people are going to be blaming my prompt, like, what is wrong with this prompt, right? I mean, you can write it in a different way, obviously. But anyways, I was able to get Wolfram Alpha doesn't understand your query. That was the goal, okay? All right, hopefully no hard feelings. Now, here's what I notice. I got this expression, and can I flip both sides? And I'm like, why not? Let's do it. So when we flip both sides, this is going to be that z plus 1 over z plus 1 over dot 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 is going to equal 1 over I minus z. Great, nice. What are we going to do? Well, we can kind of subtract z again, right? We can subtract z from both sides. Is that going to help? I doubt it, but let's give it a try. And now we're going to get this. And now we can do the flip one more time. But before we do the flip, maybe we should make a common denominator. You know, let's go ahead and common denominate this. 1 minus iz. And then plus z squared divided by I minus z. Okay? And then we can flip both sides again. That gives us z plus 1 over z plus 1 over z plus dot 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 is equal to, we flipped it, we got this one. And on the right hand side, we're going to get I minus z divided by I minus iz plus z. If you want z, you can write the z squared first, kind of like put in the standard form, and then kind of go from there, but it's totally up to you, no big deal. Now, where do we go with this? We keep doing it, and then we can subtract and subtract and subtract. But the thing is, the stuff on the left-hand side is very unwieldy. Like, it doesn't yield to anything simpler, right? We keep getting the same thing. We got 1 over something and then z plus 1 over something. It's infinite, guys. Come on. So this is not going to get anywhere. Maybe it does at some point. We're going to get something nice from here eventually. Maybe. I don't know. I haven't tried it, but at least I tried. So let's go ahead and proceed with a different method, and then we'll check our work. Okay? Awesome. Let's go ahead and take a look at it. Second method. First method did not give or produce any reasonable solutions as far as I know. So let's rewrite the problem. And now this is equal to I. Not that I, but I, myself, notice that This expression contains itself. You probably noticed the same thing, but don't tell anyone. This expression contains itself infinitely many times. For example, this one right here is the same as the original. This one right here is the same as the original. And you could continue doing it. If you continue doing it, is that going to help? Maybe, who knows? But let's do this. Let's stick to the first one, the first bubble, the big bubble, and replace this with this because they are the same. You see that? So this is the same thing as I. In other words, we get z plus 1 over I equals I. Wow, that's really nice, isn't it? Yes, but we need to simplify a little bit. Well, a lot of people are going to multiply by I, and then they're going to multiply by -1. What's the point? Just multiply by -I, and you'll be done. Why would you just beat around the bush, right? Okay, directly go for the bush. So here we get -I squared, which is 1. Awesome. That gives us the following. This is -I, z plus -I, z minus I equals I. If you add I, me to both sides, you get z equals 2I. This is amazing. But you know what? We're going to check our work because what if this doesn't work? But that's the only solution we have. Maybe there's something else we're missing. Let's go ahead and check it out. We always need to check our work, right? You probably realized for the other problem that I did on my other channel. Did I talk about it? If not, then it's cyber math. I do number theory and algebra videos, but that's cyber with an S. Make sure to check it out, okay? So we got this equals I, and now this equation claims that z is supposed to be 2I. So can we just replace z with 2I and see if this is actually going to work? But here's the thing. If the whole thing is I, right, then this is also I. Yeah. This is also I. But z is 2I. Be careful. Don't replace this and that with 2I at the same time. What do I mean by this and that? I mean this and that. You don't want to replace them at the same time because they're different, right? So z is 2I and this whole thing is I. So we're going to get 2I plus 1 over I. And now multiply by -I again. It's the same idea, but we need to do it. This is -I squared, which is 1. That is 2I minus I equals I. Now here's a $1 million question. Is this valid? Is there any other solutions? Or is this the only solution? And is this solution valid? Can we really talk about an infinite fraction with complex numbers or imaginary numbers? Those are good questions, good things to talk about. And like I said earlier, there is no result from Wolfram Alpha. So the only thing I can show you is that it doesn't even understand your query. So too bad, humans win this time. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.